Hi guys. So today's video is a bit of a departure. We're kind of moving on to the more ethereal, as you saw in the last video. We're going to the more ethereal parts of the computer science course. Today we're going to have a look at universal design, okay, and how it the principles of it and how it kind of infects, or how it, as you as a computer programmer, as a computer designer, or as a kind of computer science person, how you will use this idea to create interfaces and the factors that will affect its usability and all that. So we're going to dive into it today. It'll probably take a couple of classes to kind of go through it all, because it is a very kind of it's not as tangible as some of the other areas. But again, once you have a tiny grasp of it, you should be grand. So we're going to have a quick gander at it, as the man says. So we're going to have a look at universal design. Okay, so there's a number of principles. The first one is write it down: universal design. So a quick blurb about universal design. It was developed in the 90s in America, and there's a number of principles, and it applies right across the spectrum to engineering, anything in STEM, anything where you're trying to design some process that people will interact with. Okay, so that's the kind of idea with it. So I suppose the first principle of universal design is what's called equitable use. Okay, now this will come into real kind of focus when you're doing your project work. Okay, so looking at all these areas. So I suppose the first one is equitable use, and the idea being that whatever you design is it's useful, and more importantly, marketable to a wide range of users with, I suppose, diverse, best way to the abilities. No point in putting the word disability here, but rather diverse abilities will kind of be a catch-all for it. So it has to be able to be used by a huge amount. So when you're thinking about, let's think of an example. So for example, let's take the calculator. Okay, diverse abilities: big screen, okay, big font, simple colors, black and white. You can see here that the black buttons have white, so there's contrast there to help people. You can see here that the yellow are in a different color for the secondary function. There's red for another, there's blue for another. You got your lovely bit of chrome here, and then you got the reverse here, white with black. Okay, you've also got other things universal designed, a common keypad design. Okay, you see this on most computers. Okay, any computer has a keypad. It starts at 0, bottom left, top right is 9. Okay, it's just the way they are. So the principle of equitable use is quite important. Can it be used by a lot of different people? Okay, so the second principle is probably a tougher one to nail down, but I'll give it a shot anyway. The second principle is the principle of flexibility. In other words, can your design accept a wide range of preferences? Okay, and abilities, I suppose. In other words, let's say you're designing a computer, a laptop. Okay, standard laptops, are that L-shaped when you open them, but can you make the hinge in such a case that it can be turned into a phablet, or a tablet, so that people that can, a person could be looking down this way and see it, but also the person who's looking this way will be able to actually see it as well. And you see that now with a lot of, they have a full 360 or 180 hinge. So that's the kind of idea, the flexibility, wide range of uses. Can it just be, is it very narrow focused use, or can it be adjustable to other preferences? People might like it this way, they might like it that way. You often see it with those new Microsoft Surfaces, a detachable, it's a tablet, but with, the detachable keyboard, that kind of idea, multiple uses, okay? Something as simple as a scissors, left-handed scissors, right-handed scissors, is there a universal type of scissors? Okay, so that idea of flexibility of use, again, quite important to the kind of whole idea of it. Okay, let's think of another one then. I suppose next one, probably one that's key principle, simple and intuitive. Okay, so design that's easy to understand regardless of how much experience the person has, the knowledge, the skills, or their concentration level. And intuitive, it makes sense to do it this way. Okay, think of all your different phones. Okay, I have a phone on me. I do. Okay, think of a simple enough phone like that. Okay, the swipeness, the buttons on the side. Most people are holding it in their left hand. Hence, you have the buttons on the left hand side. Okay, does that mean that what happens if you hold it in your right hand? You're kind of screwed, and you're using thumb to do that. So they're built this way because the vast majority of people are left-handed or right-handed. So you hold it in your left. Okay, is there enough space for it to swipe over? You see, there's a certain amount, your ligament there. There's actually research going in to show that ligament is will eventually evolve to be longer to allow people to actually stretch that full stretch of that type of way. So simple and intuitive use. Okay, most people call it the Ikea principle. This principle. In other words, it's so simple that it's like putting together something from Ikea. It's that simplicity, and it makes sense to put it together in that order. That's what they're talking about when they're talking about that one. The fourth one then, I suppose this one's this one is definitely more what I would consider a more in-depth one. And this is idea of perceptible information. The idea here is that the design, whatever you're building, communicates necessary information effectively, regardless of the conditions of the user's surroundings. So, for example, let's say you're in eventually when you get back to an airport, okay? An airport, you're going to have different languages, different customs passing through that airport. If you're to design a navigation system through an airport to get the person to the right place, okay, you could use color codes, you could use universal symbols, these type of things. You often see it. For example, there's a universal symbol for a train. It's like that. I think, oh God, that's the worst. You get the idea. There's a universal symbol for train, for bus. Bus tends to be a sideways view, doesn't it? Okay, and taxi just tends to be with the word taxi on it. That type of idea. So universal symbols, this idea that the idea of how is the best way to put it, of getting as much information to the person in the minimum amount of effort. Okay, so a very, very simple one is at the edge of the train tracks, it goes yellow, and you got those little baubles on the platform right at the edge. Okay, now what are they telling you? That, well, if your foot, when it moves from the smooth pavement onto the baubles, you've got a change in perception of the foot. So you look down, oh God, what's that? You'll see the yellow. Yellow is not a great color. It's usually it's associated like red. You're at that end of the spectrum for kind of danger or warning signs in yellow. So you might step back so you don't fall onto the track, that type of thing. So that's the kind of idea there. Okay, it's not just for blind people, by the way. Those little baubles, they're actually for you because you're watching your phone, you don't know how far you're stepping forward, you feel the difference, and suddenly oh yeah, that's what I meant to do. So that's the idea of perceptible information. Can you do it regardless of what's going on, can you get the information to the person? That's really what they're talking about there. So it's a tough one to kind of get across, really, when you're trying to actually design something. If you're designing your artifact at the moment, what do you need to get across to the person in terms of the information from your design? And how would you do it the most efficient way possible? Now, the next one, I suppose, next principle is the tolerance for error. Okay. How can you design a computer artifact that allows for the fact that human beings can be quite stupid in terms of their use? In other words, this phone has been designed for a certain amount of droppage, reinforced a little bit, Gorilla Glass maybe to stop it from cracking. It's also designed with things like a restore point. So every so often it takes a picture of itself in terms of what's on it, app-wise, data-wise. It uploads it to the cloud or sets a restore point so that if you by mistake delete something, you can find it again. The easiest one I've ever heard of was Microsoft's undo button. Or as you're more familiar with, just Control Z. That is the greatest piece of tolerance for error design in the history of mankind. Okay, so when you're building tolerance for error into you, how much do you do? If you overcompensate for it, you make it too complicated, actually. So you need to be able to design for some of the worst case scenarios, but not them all. Because if you try and design for every worst case scenario, you overcomplicate